it's time for us to really shake up the system a bit, because we've been looking at robots and trying to design a taking person-centered approach to designing assisted robots for many years. However, we still don't see these robots become ubiquitous around us. And so for me, the last few years of my research career have been very much about, there we go, reflecting and working with the people that we are designing the technology for, the people who are going to be working alongside the technology, to really deep dive and understand what the barriers are to getting these technologies out there. So in my session today, I will give a quick review of my research group, my new research group that I've started at Nottingham, and go over some of the complex and changing user needs. We have heard a lot about the motivation for assistive robots in the previous talks over the last few days, and I want to just focus a little bit more on the active users. Also, this concept about understanding that these technologies are very disruptive, so they're going to change how we do things and how we our assumptions about the current healthcare system. And then from there, very much to the core of my current research is we're developing all these technologies as roboticists, computer scientists, engineers, psychologists, but the people who are going to be working alongside this, getting the information from these and putting information into them, are people who have been trained differently to us. And so what do we need to do to our systems to adapt and change them so that it becomes easier for people to connect with them and understand how to customize them? And then if we have time, I'm going to look a little bit into some work we've been doing on gaps in standards and assessment methods at the moment, because without going through formal processes or assessing these systems, no single healthcare institution is going to allow these systems to be used in their settings. So the medical device industry is very highly regulated. And then look at these emerging challenges and pass it over to you. So my new research group, Psychophysical Health and Assistive Robotics Technologies, is particularly responding to what you guys are doing here in your Marie Curie ITN, because we have seen now that it's not just about that single robot or single set of robots, but it connects with the whole infrastructure, the cloud-based services, etc. And so that cyber-physical aspect is crucial for us to be able to realize the benefit of the assistive robots that we've been exploring and designing. Some of the foundational topics, and obviously robotics, assistive robotics brings together, combines a whole range of different foundational topics. And so really it's about understanding and bringing together topics and themes like safety and benchmarking, user-centered design methods and applications, autonomous systems, and guided manipulation, etc. We're also looking at actual robotic systems and telepresence and teleoperation, whereby there are a whole host of specific issues to consider. The whole idea of accessible human robot interaction design, because our end users are people with a range of impairments, which I'm going to get into in a moment. Mobility and navigation as a foundational topic, smart sensing, and embodied intelligence. And of course, last but not least, the ethics and responsible design. So I'm building up the area whereby we can find expertise in each of these specialisms. These people work in different application domains, but coming together specifically in healthcare. And so the focus of the research group is to develop research which looks to develop socially and physically assisted robotic intelligence, and this is the keyword personalized systems, and what does personalized mean? Thinking about the themes in terms of variable autonomy, something that we haven't quite touched on. We either talk about fully autonomous systems, but there is a human in the loop. There are quite a few humans in the loop. There's a carer, there's the person using the robot. And we quite often make an assumption that they are just there and we need to do things for them. But we can reverse that. We've still got a lot of barriers in terms of realizing the more nuanced aspects of these technologies working in the real world. So why not bring the human in as an additional intelligent collaborator in the loop to be able to then provide information about, no, you're going to bump into that, move away. And they can do that when people want to do that. So I'm looking more about the kind of then architectures that allow for the human to be that additional sensor, if you like, within the system. Looking at developing smart devices and technologies, this is about mental health and improving health behaviors, intelligent sensing. This has been a focus of my research for quite a few years as well, which is about using self-supervised learning methods to be able to understand patterns of behavior. Accessible interfaces, of course, as I mentioned. And then this last point here, decision support systems with easy-to-use dashboards and tools to healthcare professionals. So we've got, our systems can generate a lot of information which healthcare professionals can use. However, we know that they're time constrained. We know that they will be wanting this information in a way that is actionable rather than spending time trying to assess what this information means. And that actually requires quite a lot of additional effort in terms of the type of skills, data, information visualization, and psychology, etc. So robots. We've looked at, actually, it's quite interesting in all the talks, people have been having different ways of presenting and categorizing these. So I take quite a functional perspective on how to try. Oh, sorry, my slides here are showing a different slide, the next slide. Some of the research topics that projects that we're covering in charts. So myself and my new team are working on a whole range of projects with different funding bodies, which is quite interesting just to note, because quite a lot of our research is about focused on getting the funding, and then the funders have got specific objectives themselves. And one of the things I found over the years is that we are quite driven by the motivation of the funders quite often, and particularly the time cycles and the funding cycles and the durations of the projects. And one of the things that is perhaps stymieing our research is because we are dancing to the tune of the funders. So it's quite interesting rethinking assistive robots is how we emerge from that, the constant ferret wheel of going round and round, doing the same thing over and over again. How do we break out from that? So that's quite an interesting thing on its own. So quite a lot of interesting projects. And then, yes, categorization of assistive robots. So we've been seeing different ways of ways in which people have been showing you assistive robots, and I take a very functional approach to what are they doing. And so my categorization is about domestic service, social companionship. I call extended living applications with instrumental and activities of daily living and activities of daily living. A combination of some of the other ones as well. But in order to be able to sell these technologies, in order to be able to market them, in order to be able to define the USP to the end user group, it's very important to be able to say, so what particular gap does this technology address? What is it going to help? Who is it going to help? Exactly, not just older adults. Who are older adults? I'm almost an older adult. Older adults isn't one homogeneous group. It is about who is the person in terms of their particular assistive need at that particular point in their lives. And so one of the reasons why I think we really need to rethink the technologies is to be able to understand and develop these in a way that we are clear about who the end user is, because without that, we are not ever going to be able to think even about what are the metrics by which we measure success for that particular person, by which we define the requirements and constraints within the system. So let me give you an example of a mobility robot, the Leo Walker. So this was one of the ones that we were really excited about. The first robot to hit, assistive robot to hit the market and be developed. It was developed through EU funding. Excellent team worked very closely with end users, aesthetic design, thinking about the configuration. Unfortunately, they went bankrupt 3 years ago now, and we purchased one of the robots that we were going to purchase, me working alongside another carer institution, another few. Why did they go bust? Well, there wasn't any specific defined user group for their technologies. It was initially designed the system for people with Parkinson's. Parkinson's people suffer from what's called freezing episodes, so they're trying to move and then they freeze. And one of the things that you can do is give them some kind of synchronized rhythmic beat, and that helps to keep the rhythm of their pace and ambulation going. And so this offered haptic and auditory rhythmic feedback. It also has 72 sensors on it. It's also got 72 sensors, and the CPU is very limited. You can imagine that we're trying to do all the processing of that. The performance was affected by that, the battery life affected by that. From a pragmatic point of view, £12,500 for this device, compared with $44.99 for a rollator. And the health economics case needs to be shown before any institution is going to take this. So our responsibility as well when we're designing these technologies is to be very aware of what are the metrics and criteria for the people who adopt and purchase these, for the people who have to sign that checkbook. You have to be able to show clinical evidence, efficacy, and benefits in the long term. Now, some of these metrics are very qualitative. It's about improving quality of life. The fact that somebody hasn't got to stay in bed till the carer comes and gets them out, or is going to miss their book club because they can't get to the place. Now, these are important measures, but we fail to be able to highlight those and identify those as well as we can. So being an advocate for your end user is a key part of your role in developing these technologies, and to be able to capture the voice and input of the people who are going to benefit from these in terms of being able to sell with actual, literally sell, but also market this. So where are we? We are seeing a change. This is the patient care continuum. So as people start to get frail, as we start to get frail, well, one of the things we're trying to do is prevent the onset of long-term conditions, which are going to accelerate our journey across to not being very well and ending up in hospital. So that prevention side, that's been ignored and neglected quite a lot. In some countries who have got more private health insurance, then that is an economic driver for ensuring that people are more vigilant about their health and well-being, because their insurance premium is likely to go up if they start to develop quite a few issues. So one of the things that's quite interesting for us is the push from the market in terms of adoption of these technologies. So in a welfare system, it is very much about firefighting. Let things get worse, nobody find money for it, and then you end up in hospital, and then you never leave, because at the other end, it's also quite difficult to be supported. Because we know, and we've heard this over and over again across the full spectrum, is a shortage of care staff. But there is also issues around more reliable interventions to reduce hospitalization, and this is key, reliable. If you have things which are producing a lot of false positives, they're going to create much more work. But from a regulatory and legal point of view, we always try and bias the system so we don't miss the positive cases, which are rare. And so there is this really big conundrum about getting the balance right. And then we've got at the other end is, at least in the UK, a very medical model to aging and conditions where it's very paternalistic. So doctor knows best, you go in there and then they think so. However, with Google, everybody's become an expert on health conditions. You have one symptom and then, you know everything about like 6 different diseases. And then you really irritate your GP when you go and tell them, I looked on Google and I think, but we do need to consider how this technology can perpetuate and embed health literacy in the population as well. So it's not just about telling the person, drink some more water, but also could the robot explain to them what's happened in the last 24 hours or over the week and what else they've been doing, and explain to them why they've ended up where they are, and to be able to work with people as a personal trainer would, to be able to help them better understand behavior. It doesn't happen when you tell people don't do that. It happens when you try and explain why, and then you get people to make small step changes, and that accumulates into behavior change over a period of time. And then we've got a big issue around social isolation. We've grown up now in our society to be more independent. I know in some parts of the world, including where I come from, India, we have lived in more community environments, and that makes a big difference in terms of having a support network around you. Quite a lot of the technologies we're developing, if something goes wrong, there's nobody around, no friends, no grandchildren to try and help you fix it. It's the person all by themselves. So accessible interfaces, etc., are important. So if we start to introduce technologies within this kind of infrastructure, what's going to happen? The things will change. We're going to change assumptions and people's understanding of things and the way healthcare is delivered, our assumptions about who is responsible for our healthcare and well-being. And then we've got this big issue around people change over time. There is no such thing as designing a system for older adults. People have got a whole spectrum of conditions which change over a period of a day or a morning. I get up with my joints quite stiff, or end up with my joints quite stiff, or if I've been sitting 5 minutes and, or if I've been doing something the previous day, then, my body will complain the next day. If I've got tinnitus, and if I'm very stressed out, my tinnitus gets quite bad. And then that affects my hearing as well. So all of these things change. And so if we're developing the system to function reliably and safely, we have to develop the right kind of sensing and temporal framework to be able to understand what are these changes, what is this person like at the moment. And again, it is not up to, you don't have to assume that sensing has to do it all. You can always ask the person. And obviously, people have different, the reliability of self-reporting subjective measures is well known. However, you can then integrate that with existing quantitative variables and learn over a period of time. So understanding all of these types of, the fact that these impairments will change over the life course, but also continually change at different speeds with different levels of severity, and continue to improve. Maybe in some cases, somebody might have realized that they need to get a new hearing aid, and then suddenly they've got better hearing than they thought. So all the problems that were arising before, are not there anymore. We had an interesting issue around when I started on my very first project, and we did some studies leaving a robot with people just for a day to start off with. One of the things we found is people wear dentures for teeth, and in the morning, people are not always wearing them, and that changes speech. It changes how somebody talks, and little things like that will have an impact on what's happening. And together with that, we did a study with some care provider in London, I think now 6 years back. And this is a tag cloud showing all the different conditions with just 20 of the people that they were supporting, 20 of their service users have. Look at that range of different impairments. And of course, dementia was one of the ones that was very prominent. But all of these have an impact on people's accessibility of the system, how they interact with it, but also from a cognitive point of view, how they perceive it as well, and how they sense make, and what they particularly need at any given time. So it is a very complex scenario. So the rest of my talk, I'm going to mainly focus on physically assisted robots because that's where my research has been going. Well, socially assisted robots are great, but at the moment we don't have much variability in the market. And what we do have, it might be very well suited for children, but for older adults, I've had experience of reported issues around it being quite patronizing. You know, so how many platforms that we've got that we can use for longitudinal studies, etc. And maybe the now, but then it heats up our it has to be plugged and it's more appropriate for children. So from a point of view of, and then also trying to address and understand what the actual needs are, to think of myself when I'm not able to support myself. What is it that's going to matter to me? Yeah, personal hygiene, being able to get out of the house, be able to go and do my own shopping, be able to clean my own house myself, not being reliant on people if possible. Physically assisted. So on the right-hand side there, it was a ceiling-based system that we developed with an innovative project. One of the reason the ceiling-based is we know that if you look around you for a mobile system to move around, it's going to be very difficult. You look about, wow, there's a lot of space there. And we haven't exploited that space enough. So in care homes now that they're building, at build, they put in ceiling hoist systems which can take the person from one room to the other, but they have to be supported by 2 people. So we decided to use the same infrastructure that's available for a system and to be able to develop a robot that can be like a modular Swiss Army knife. That's the other thing to think about, the functionality at different points in our life, different points in the day. The robot has to do different things. And that's why I use that functional categorization. In the living room, it needs to do different things for you. In the kitchen, it needs to do different things for you. In the bedroom and bathroom, it needs to do different things. So how many robots are you going to have in the house when you really need them? So can we design a modular system where the end effector can be swapped or swapped? So that would be the idea. Still many years to go. We've got lots of time for research still. Anyway, so we looked at 2 use cases. One was mobility assistance, getting people out of bed and being able to walk around the house to the toilet and bring them back. And then we also had pick and place around the house in the living room area. And then we purchased the Leo Walker, so we did quite a lot of research. Even though the battery life is not very good, 72 sensors gives you amazing data to work with. So we'll still continue to use it. So physically assisted robots. Now, if we want to get these robots out and into operational use, the key thing to remember is that they need to be accepted in the first instance by regulatory bodies. Yeah, and we need to be able to conduct comprehensive risk assessments to ensure that we've addressed the technical complexity of the robot systems, and we've got enough data to be able to prove that it's going to operate reliably in different situations and contexts. So one of the things that I have discovered is that we need to think about it at the design stage. We need to have the systems that are able to capture this data. It's not something to add on later after you design a system. This is something you've got to think about doing when you design the system, because like the Leo Walker, there wasn't the capability and capacity with the integrated CPU that they had on board, the memory that they had on board, the connectivity and their own cloud infrastructure that they had on board to be able to do this. So we, at the moment, need to start off with working backwards. Okay, was there, what is it that would need to be proved to get it through the door of a healthcare organization, or somebody from a liability legal point of view. And you don't want to run over and kill the cat in the first day. That your workers really have love to sit around these things, as we know. And people do have cats and dogs and with tails, which can be run over. Risk assessment is not straightforward. And so where I'm going back to in my research is thinking about, well, what are the contexts in which these systems need to be used in, the cluttered environments? How do we make realistic testing in environments within our own labs? Yeah, so our own living labs, to be able to set up these messy, noisy, real-world environments, turn the television and radio on really loud, and then do your testing with the user over a period of time. And where else will these systems need to be used? So where are we going? So we use contextual inquiry quite a lot. So going and visiting people in their homes to see what that home is really like, and then come back and recreate some of that in our own lab. And listening, really listening to the issues that people have. So this was some contextual inquiry work we did with somebody. So in the UK, people have these types of boilers, typical boilers, and the pressure often gets changed, and you've got to go in there and fiddle underneath. Everything drops out. You can never put the lid back on. If you've got visual impairment, etc., you could never really figure out how to do it. And I love capturing how people talk about these technologies, because it's really interesting, because that's exactly how they would talk about your robot as well. So, so let's see if I just got this, and then it's gone. Where is it? Let's see. Okay. I should have brought my mouse, sorry. Not really good at driving this.
There's a key. So, there's the key. Now you've got to try and get that key to go underneath there. They're talking out the back of their... Yeah, you just imagine all these pensioners trying to get underneath there.
And something, you know, makes people very anxious. One of the things to remember is anxiety limits our ability to think creatively. So we start to focus, and when we start to focus, we get very anxious and panicky and stressed, and you'll see the body right in front of us, and we won't be able to see it because we're already stressed. And that affects how people perceive it and think. People, we, I have to talk about myself as well, live in very cluttered environments. We were looking at medication management and how people use them, where they store their medicine. So if the robot wants to give them, say, it's time for the medication, we find that's where the medication sits together with the partner's medication as well. And then people's own perceptions of their ability to really understand that, to be sensitive to it.
Well, walking for me is a bit of a problem. So if I walk 40 metres or something, and I've got arthritis in the toes, so that gets painful. I've also got gout, knee pains, yeah, all that sort of tendonitis, the Achilles tendon. I've got a little bit of that now. And these tend to vary a bit. So I've got a permanent problem of walking distances. And then I get all these other things coming in occasionally as well. So have those and backache at the same time, and it's like.
And pain is something that I haven't realized as I enter my 50s, my mid-50s. Suddenly, the body is just starting to break down. And, you know, you've been sitting in a chair for a while, you get up and it's like, urgh. And the pain clouds your judgment, it clouds your ability to want to do anything or interact, and how you want to do it, and what you want to do, if you're going to be using a display or in your hand, is how long you're going to be required to sit in front of the system to use. the thing, if you're going to get distracted, if it's time to have your nap or your lunch, what time of day it is, how alert you are, etc., etc. So if you were to do hazard analysis and safety assurance, it's really important to be able to take in these considerations as well. So while we've got lots of common hazard analysis approaches, they tend to be very internally or mission focused, and they don't address these other types of issues that I've been identifying and raising. And this is a major concern for the types of systems we're developing. So, we've got a lot of different approaches that, failure mode, effect analysis, hazard and operating systems, and we can build on those, and that's what we've been doing, building and drawing on those, but we find that they need to be adapted. So here is a big area of research which is currently being ignored in terms of how do we do this. And also, it's being ignored because we've got an opportunity here. We're developing systems which are rich in sensors, which could do this automatically themselves. So in terms of predictive maintenance, which we already see being integrated into things like washing machines, etc. How do we do predictive maintenance, predictive risk assessment as the context changes, as the condition of the user changes, to be able to then address some of the things that we do need to get past the regulators without happening. So we've been looking at this method called environmental survey hazard analysis, ESHA. And this has been really helpful in being able to look at noisy environments. However, it lacks structure. And so we've been looking at some other types of available approaches. So one of them is ecological interface design. And this was used for dynamic systems as well. And it uses a skills, rules, and knowledge framework that helps designers to combine information from a system, but more importantly, from human cognition. So the user in their particular level of mental alertness. And how then do we bring this into the design of the system? So one of the things that we've been doing is working towards creating a neurological framework. So with my former colleague, so liaising with Dr. Chris Harper at the Bristol Robotics Lab, who is a safety expert, working to look how we can progress ESHA, which was developed to identify environmental features, and think about how we can introduce some additional ontologies to be able to try and make the whole process particularly more robust. So I've got our paper that we're starting to develop, which is a position paper, to try and look to see which were the most relevant ontologies, and we found that a combination of the two was going to give us quite a lot of structure already to get started. So this is work that we are currently pursuing, bringing together these models to represent the dynamic real world, which also includes a component of the user as one of the elements that we have got to consider and assess as being the hazard in the environment. And that was really brought home to us with some studies that we did with another physically assistive robot we were trying to develop, which was progression support. And we were looking to see, yes, it's all well and good when somebody's sitting and using the system one-to-one with the file, but the phone's going to ring, somebody's going to come in the doors, somebody's going to, a wind will blow and something will fall off the table. And there you are with your robot in a physically vulnerable position, and suddenly something happens. How is the robot going to react? How do we know how the person will react? Do we have models of that? Do we understand the different situations in which you can actually harm or injure the person if they do get distracted at that point? So trying to conduct these types of studies to look at these safety related human factors issues are really important as we develop our systems as well. So in addition to our usual framework of the usability and user acceptance testing, trying to address these issues is really important. So here is research is trying to get dressed And the video plays with the trouble. So the Baxter robot, one arm in, next arm in, wearing an exosuit, doing getting this getting cognitively loaded with having to do a puzzle. So that's fine with the structures, proprioception, neurotransmission, that's I do the other hand in the jacket, all well and good, back it on. See how close arms have to be to the head, so from the weight distracted, the robot moves perfectly, we know Baxter is a compliant robot, but still, it does, for somebody who is already vulnerable, it is a risk business. So then we now give them some tasks to do, and we'll have a look at that. Right. Left. Left hand. Right. Right. Left. Down. Down. Right. So this is lesson 2. Right. But one of the other things to note is the ecological validity of this type of experiment as well. We have asked the person to do a particular task. Yeah, so therefore their focus is shifted to the task. Then we're collecting data about whether they can feel and put the jacket. And of course that fails. But after a while, it improves. Then we put together, so that was cognitive loading, and we got a little distraction. We were thinking really hard what the distraction should be in this setting, and we've been exploring that, and that itself is a research topic. How do you distract the person, which is in a way that's going to be logically valid? I'm not sure this is, but it was interesting. We got a toy clockwork mouse that we could make run across the field. We have to have some way to get them to move their body and to raise their head, etc. So here we go. See what happens. Top. Left. Right. Left. Bottom. So after we found that we did not control it was quite a bit situation. And then the other aspect is okay. So what happens with all of this? What happens? And there was some really interesting results. So we had this first study. You can read more about it. So this was the number of failures, and we had a lot of repetition with cognitive overloading, and you can see the falls. Yeah, so we are really good. We adapt to situations very well. We understand those, and then we learn what's going to happen, and we start to refocus, and everything's fine. But the problems happen when that change is new, and we're not aware of it, and that happens. How do we make sure we have design? And this is what going back to the model, risk assessment and hazard analysis, that the system knows what the user might do, what kind of model do we have, how are we able to incorporate that model into the control system and architecture, and what should happen when the user gets distracted in those initial stages. So we continued with those studies. So yeah, we found mistakes occur more frequently when the new distraction stimulus was introduced, and participants adapted very quickly to the distraction. So we continued those studies, and we improved on the methodology in terms of making it experimentally more rigorous. So we had the dressing sequence. We were able to tag and map each stage of it. We were introducing the distractions exactly at the same point, etc. We gave the person a period of learning so they get used to doing the thing in the same way. So we weren't telling the system what we learned. And then we started to look at the results, and then they are proving to be much more reliable in terms of helping us work towards a model, a very structured model of cognitive response and behavior in different situations. So this study is continuing with our PhD student, Antonella. Actually, is also a military student from the Socrates project. And so, what we're doing, yep, I'm going to hurry up. So we've been doing more studies with that sit-to-stand robot. Again, similar sort of issues. We collect a lot of data about measuring movement and behavior, but how do we, at the start, we can't bring a vulnerable user with stroke to be able to trial the system. We want to be able to see what are the issues when things go wrong. And so we talk to our end users and carers about what could go wrong. And you'll try to read this, but these are all the things that they said would go wrong, which we've never thought about. How do you measure it? How do you measure all of this going wrong? How should the system respond to it as it starts to happen? And if you take the system to them, they'll immediately come up with this and say, what's going to happen when? And then you go, oh, no, it's very early stage. And they go, oh, yeah, come back to me when you're ready. So we've got to be able to do our development of design rigorously at the start. So these were things that could go wrong with the user. Then there were things that could go wrong with the robot, which they also pointed out themselves, you know, equipment failure, breakdown, etc. What do you do with this poor wonderful person stuck in the middle of the room with nobody around to support them, apart from the cat, which will then decide to jump onto it and pull a wire up. So one of the other things, noise levels. These machines are pretty noisy. Yeah, you turn on these, and we get accustomed to them. You take it into somebody's home, you switch it on, and they go, "What is that? That's really loud, isn't it?" I don't want that. I don't want the machine whirring constantly. The fans or the things going to cool down this computer you've got. Yeah, lots of issues to consider. And then it's about collecting the data to be able to do falsification testing, for example. So we use an aging simulation suit, and we work with therapists to try and see, with the aging support suit, how can we restrict movement to try and simulate different conditions of what will happen to the user, or whether they are mobility restricted in different ways, or when they fail in different ways, when they are fatigued in different ways, how is their body going to respond? So a lot of this is about building up these data sets to be able to then start to use them and be able to do falsification. And I'm going to tell you a bit more about it. I'm going to rush through this because I just looked at the time, about 10 minutes, I'll give you some time to ask questions as well. We've been reviewing some of the regulatory considerations, and we find that there are big gaps. Paper there, we've started to look at what these are. And then one of the things that we are going to do now, which we're hoping to put in for funding, is to work with the BSI. There is a big gap in the types of robots that we are, the physically assisted robots that we're developing. And we are going to be looking at putting together a new framework, a new set of standards, because we don't have these. And then we've got to, again, like I said, work backwards. If we've got the standards, how the system is approved, that the system conforms to them. And one of the other things is that the 13482, which is our key standard for personal assisted robots, has got very large areas whereby you can't bring the robot close to the user to be able to allow them to see the screen, for example. So our screens are very small, the batteries, the lights shining on them, they can't see it, they can't hear what's going on. This robot's articulation of words doesn't correspond with the lip reading they've learned to do. They can't hear what the robot is saying to them. Very soon it becomes very frustrating. So we've got to reconsider how we have come up with these ideas of space between the user when they're interacting, slowing speeds. How does the person know that the robot's actually going to come to a stop as it's approaching them? What are the indicators and markers which can be intuitive and not be missed from a safety point of view? That's going to be important. Little studies which we started to do about, we get stuck in the corridor, you go this way and you go that way, and then what about the robot? How do we try and work through those sort of situations? Obviously, we know a lot of this depends on the embodiment of the robot. Our own intuition is based on our presumptions from our mental models. So a lot of work to be done in terms of understanding what existing regulatory frameworks there are, because these are ones that have been developed through a lot of work. These are ones people learn and train on, and do have to do tests on, and the systems have to be tested on these. So we need to ensure we are aware of them to be able to incorporate them into the systems that we design as well, including things like the Health and Social Care Act, etc., about how do we incorporate service user preferences into this. If we are designing in our own little bubble, that's where we will always stay. So, working with people, the stakeholders, end users, carers, informal carers, healthcare professionals, people who sign that checkbook, who are not carers, healthcare professionals themselves, they are managers. What are the things that they're concerned about? Yeah, and then we look at our robots, and we look at the range of different robots that we've got, and we look at the continuum along the level of physical assistance that we're looking to provide, and the level of physicality of that interaction that needs to occur to make that interaction appropriate for the functional task that they're going to perform, the type of support that the system is performing, and oh my goodness, I hadn't thought about when the system is going to go into somebody's home, how is it going to be initially configured to that person's physiological and cognitive state? What is our calibration process? What is our deployment process? How is that incorporated into being confirmed and checked and operated within that person's environment and home? If we haven't thought about the frameworks, software frameworks or the interfaces to do that, you can't do it after you spend 6 years developing the system on millions and the system's all ready, and you realize you try to cut costs and put in a CPU that's not going to be able to cope with any of this, or don't have the interfaces to integrate. The adaptation mechanism, is that appropriate? What is appropriate for me? How is that going to be measured? What needs to be adapted as a person's physiology changes, as their cognitive and sensory systems change? Should the robot always assist? This is a really big challenge for us, because if the robot's going to do everything for the person, soon they will start to lose interest and not be cognitively stimulated. We are people who like to figure out, humans are people who like to figure out, beings who like to figure out how to do, that's what keeps us smart. Quite a lot of dimensions are picked up for people who are actually more mentally alert and doing things with friends and going out with family, etc. If we allow the robot says switch off the light now, or do this now, and do this now, what happens to us? What happens to our ability to be able to recognize and preempt that? You know, we hear the sounds, particular sounds, and our brain is primed to recognize that as a hazard. If the robot starts to do that for us, then what happens to us? And how does that have an impact on us? That's a big challenge. And then the things like routine maintenance. What kind of cleaning fluid that they use to rub down robots. So we've been working and doing this as part of a project prompted by the Topol report, which is really interesting to be the thing there, preparing the health care workforce to deliver the digital future. And then working with carers to try and capture, and healthcare professionals to try and capture the information. So usually, you know, we go there and take a data recorder, and then you get green stuff, and then something Thematic Analysis, then it gets forgotten. We're looking at different ways of putting this information together that makes it to say what the actual issue is. And I'm finding this is a really powerful way to be able to communicate to the team of different, comprising of different skills, to engineers, to actually understand what are the issues at hand and what needs to be addressed and solved. So this co-production approach is really well and good, but you also have to think about what is generated from it. how you represent that information in a way that everybody is on the same page. Everybody actually gets what this means. When somebody says, you know, that will the robot instruct proper use, what does that actually mean? You know, you're sitting there, standing there using the system, is it going to tell you what to do next? How is it going to tell you? What happens when you fail to hear that one thing? You were distracted when it said, touch me on the back of my hand when you've completed this exercise. And they miss that and they're sitting there, or they forget what was happening. What happens in that case? It's hard. Lots of different questions to ask than the ones I've already talked about. And we really need to rethink how we build in our systems so that we can answer these questions. Who does what, when, and how often? Yeah, these are things we do not know yet. We need to start to think about them from the stage of design. We've been doing quite a lot of interesting work with healthcare professionals, understanding it. I'm not going to talk about this now, but it seems to be published. I can talk about it later. But what I want to stop with is the Emergence Network, which is with our founder there as well as one of our co-eyes. We decided as a community, we want to build the robotics, assistive robotics community to better understand these issues and to bring in new researchers to work with each other in a collaborative way to solve these very, very hard problems, very, very hard, complex problems. And so we're making available our labs across the country for people to come and work alongside and use our facilities, our technology, and our know-how and our experience to work alongside us. There is still time to sign up for the event. It's online. Even if you don't intend to participate and get some money from us to do some pilot studies, because you might be in different countries, people in the UK can. It's still useful to be part of the network, because we're building a network to share our learning from the network with each other, so you stay on the mailing list and everything. So sign up, go onto the website, etc., and attend that, and then for the next few years, become part of the community, become part of our learning experience, our learning journey, where we want to propagate fundamental foundational research which addresses all the issues I've been talking about, be able to do ecologically valid in the wild studies, think about developing the standards and regulations, and last but not least, the skills and the business development. And my frustration over COVID was I had all these robots out in care organization institutions. I said, who's still using them? This is the time. He said, nobody knows how to use it. No, we're not going to touch it. There's a lot of things. And I thought, oh, what's the gap in the market? Somebody will go out there, train people, help them understand what this is for, be there for them when the system breaks down. So I set up this company with my husband a couple of years back. Robotics for Good. We're a community-use company. And so a social enterprise looking to provide robotics as a service. And we're starting with what's available at the moment. And still, it's a challenge off-the-shelf telepresence robots to try and deliver exciting opportunities for care professionals to connect people, volunteers to connect with people in their homes and support them through human-human connection, facilitated by the technology.
Thank you for the talk. And I was wondering, when you talked about risk, so you use the healthcare professionals to provide feedback about risks. But then the next step, I suppose, would be to find a way to quantify them in order to explore them in follow-up studies, and also maybe for future robots to modelize them in order to have the robot assessing them. So what could be the ways to achieve that, to get from insights from professionals to data that could be processed in studies done by your robots?
Yeah, so that's a really, that is a big open challenge and research initiative. So we started by going through, so you see here, we talked to the healthcare professionals, and we were able to identify lots of different issues. So for example, fainting from standing up too quickly. Yeah. So we said, okay, this happens a lot. People, particularly in the morning, changes the blood pressure, you go and then you just go back down. And so we thought, okay, so what we need to be able to do then is we need to be able to simulate that. Yeah, and see whether we can pick up that. What type of sensors will pick up on that one thing? And it's a layered approach. We need to do it incrementally. And then we go up and say, how reliably can we pick that up? So we've got our baseline data, and then we put on the aging suits to be able to simulate some of that, because you can't get everything to bring people in. But we are working with the care professionals in the room. Yeah, and they tell us, no, that's not the way you fall. That's like you see in a drama. This is what happened. And so then we've got more realistic data that we have collected, and we have that's what it is about. It's being able to collect the quality of the data that reflects the actual issues. Yeah. So then from there, we've got the balance board, we've got the 4 cells. Now the balance board won't be there in reality. So that becomes our go through the calibration benchmark. And then, okay, so if we can't pick it up from there, then the other sensors, how much noise is there? What sort of drift do you get in these sensors? What is the natural pattern of them? So we were looking at breaking down the movement into those stages, and from that extracting it. It's a laborious process, but it all came from saying, okay, this person will faint when they try to stand up too quickly. So you simulate that over and over and over and over again with that. And then you try and generate the data sets, which you can then start to use. Yeah, so to pull into a more structured approach. So then, okay, so we know the variability we've got. Can we generate artificial data from this point on? So this is where now my research is going towards digital twins, because that is the way I think we're going to get quicker towards something more realistic. So being able to collect this data from actual physical systems, build the digital twins, and then replay that in the real world again and work.
So, Dan, yeah. So there's been lots of difficulties and bad news. What's the success story, or how long will it take before we've got success stories in this area?
I think the success stories is why I set the company up. And I think MAJORCAs need to take that type of initiative, because we've been there working with the reality of where we are with the technology. We've got to cut out the hype from there. We've got to get in the game ourselves, yeah, and be able to understand those issues so we can bring them back to our lab and then work on them. So issues like took the telepresence robot out to somebody's home, they've got all their cat toys over the floor, yeah, and they don't want to move the cat toys. The cat doesn't want the cat toys to be moved. They'll get very upset. And so what did we do? We said, okay, so the volunteer who's controlling the robot, we told the person, look, volunteer, the cameras at the moment, they can't see these cat toys. It's out of the moment, out of the field of view. You're going to help this person. Come on now, you tell the person left, right, stop, forward. And the person loved doing that. They certainly felt that they were helping this person who they thought was the expert supporting them drive the robot. It works. And so that then becomes an approach for us to understand when we're training the user is ask the person. Is it okay for me to move? It keeps them involved and keeps them, and suddenly you could actually see a change of energy with that person who was saying, oh, this younger person's going to come in to my house 3 times a week, talking through exercises. But now, look at me, I'm driving a robot. That's what I'm doing. Those are the kinds of success stories, and we need those. And that's why we need to get out there in some way to be able to be the advocates and be the innovators of the future. It's not just about being the researchers, but also being innovators.
Thank you. Any other? Thanks for your talk. Maybe I will follow with what you just said about the cousins on the floor. So actually, my question is about the environment. How, for example, even for the new robot, having people to what we see is occupy a huge area, but I mean, normal people's house, they don't have a huge, and even this side, you have to adapt to the apartments with the roof. So, how do you see the future? So, should we design a robot to adapt to humans' apartment, or we should ask humans to adapt their apartment to our robot design?
I think it's a bit of both, because we do constantly adapt our environment to the technology. Our city infrastructure is an example of that, to be able to accommodate different types of transport. We have adapted our city. We adapt our homes. We have plug points in certain places around the kitchen and where the fridge is going to go. We change the layout of the kitchen so that we can integrate the technologies, the consumer technologies, into our home so they're comfortable for us to use. And so, yes, we need to work with people who are in architecture and the built environment to consider better integration of the robots into the built environment. So for me, the future is not this one single robot platform that's moving around. It's your chair that's the robot, it's the ceiling, it's the cabinet, which IKEA is already looking at developing, that comes down and changes and adapts, and your kitchen counter, that it becomes the robot. It's about robotic technologies, I think, that we need to start to think about, and think about how we are reframing ourselves in terms of being able to do that. But at the same time, also considering that we can't expect people to change or what they do to be able to work alongside the machines as well. But you just have to look around you in your own houses and examples. We have changed how we live so that we can fit in that dishwasher, that washing machine, and the vacuum cleaner, and plug it in and recharge it. And so, yes, thinking about these robots, or actually, this is one of the things as well. Do we really want to go down the route as much as we are in trying to anthropomorphize these things, so we start to see them as sentient beings that live with us, or are they tools for us? And if they are tools for us, which I think, yeah, I value other humans and their intellect. I don't, and our creativity is boundless. Why are we developing these other things? Yeah, let's use them as tools to improve ourselves, and then make space for ourselves to do what we do best.
And also, another thing. So it's because I'm also working on the diploma, and I see that you takes a long time to make a pretty important analysis from the technology. But how would you have a new method to accelerate this procedure to make poor people benefit from this technology quicker? And also, I don't know how long it is that everyone can use robots as a system.
Yeah, so if we look at other technology evolution models and how they've worked, we do find that there is a pattern. The early adopters are the ones who are more technologically savvy and have the resources, so they get the big mainframe computers, and then the technology becomes more ubiquitous, and then the price falls. And I think that if we look through all the different examples of the types of technology that are now more affordable to everyone, for example, the number of mobile phone users in developing countries like India is much higher than the countries here, even though they might live in accommodation that is still quite basic, with cooking on a fire. There's a mobile phone because it's become more affordable. But that didn't start off as affordable. So I think trying to pursue that is good, and we do need to think about sustainable design. We need to think about modularity in how we design it. But one key thing is we need to simplify the functionality to the most significant function that makes a big change in a big lived experience change in the life of the user, not trying to develop this thing that will do everything. That will reduce the cost to start off with, yeah? So focus on the minimal viable products. We do tend to get functionality creep very quickly with everything that we do, and particularly with the robots that we use to develop. Just because they can do it, we think we should be doing it. So again, this rethinking the robot is, yes, what is the most basic things that will benefit this person? And then that benefit metric needs to come from the people themselves. So yeah, so I think mission creep, function creep tends to put us to something that's never gonna happen. Start with something very basic, and I'm realizing that with the telepresence, you can't actually call the only platform a robots because it's not autonomous in any way. However, once you start to put on a little bit of autonomy, you see a big breakdown. So the double can do slam, but it fails and it becomes dangerous. I've seen it go totally haywire, and then you lose the trust. Yeah, so you have to also have that element that's important for trust. To build a reliable autonomous system is going to be expensive because you've got to build in redundancy. Yeah, you have to plan for failure. That will keep the cost up. I wouldn't buy something that is cheap if that is what my life depends on when nobody is around. Yeah. Trade-offs.
Let's take Praminda again.
Hey.
We were talking about how to get the leads and to have full design, and so we kind of keep the track and we will speak talking about particular design and in particular
hello, this one here, and this one. Okay. Cool. Yeah. Cool. Thank you. So welcome everybody here. Thanks Angelo, Silvia, and all the organizer of this event. I'm enjoying so far. So I'm based in Lancaster University, made in Italy, actually, myself. Move around in the last 20 years. It was so interesting to hear all the stories these days about where people are coming from. We have very different backgrounds. I will start to introduce myself a bit about that. So I'm based in Lancaster University School of Computing and Communication, and I just created my own group, namely TikTok, which is about technology, innovation, community, and children. So I have very mixed backgrounds. My degree is in HCI, human-computer interaction. This is where I'm coming from. Strong background in design and social science with PhD in computer science. So very mixed things. And I ended up into robotics very recently. I mean, I have studied in the last couple of years, but it's a recent move and very interesting to that. And it was great asset, the presentation of Tony the other day, and Praminda also. Thank you for your introduction to a lot of concepts that we use and talk today as well. So I think something that emerged very strongly in my pathway is really about responsible innovation that Praminda mentioned and today several times, and how we could, you know, facing all these socio-technical challenges in vulnerable groups that for me are children. So I'm going to talk about that today. I will do a short introduction about theory, methods, and outcomes, because I don't know if you're familiar with some of the methodology and theoretical background I'm using. I will show some research direction and topics, and then I will show you a case study example of one of my recent studies and publication. And of course, I will try to wrap up a bit. So feel free to stop and ask questions, or we can do it at the end. So my research is really about exploring socio-technical issues that emerge by the use of technology and understanding this complex interplay between artifact, human body, mind, and environment. So my approach is really to design activity that is technology-based. So I'm not designing technology, but I'm designing experience that are based in technology. And this is, I mean, the main purpose is really to look at how to improve the life of people, and especially looking at children is how to make them more aware, you know, to improve their aware as consumers, customers, and producers as well. So looking at, you know, users and specifically children as more like active in the way they interact with technology, and the passive is not just consuming technology, but really, you know, being more active even in the consumption, but understanding what are really the messages. And this is really important point for my research. So in order to meet this complexity, I mix different kind of approaches. So I have very interdisciplinary background. So part of my background is about, you know, design methodology like co-design, participatory design, approach, social science. So my supervisor, both master and PhD, was a psychologist, experimental psychologist, and of course ICT, because this is the material, right? The content I'm working with. So yeah, so my approach is really about combine all these different areas and concretize it into design and assessing digital artifact. And so maybe I have moved quite a lot in my research life and also as a student. And I think it helped a lot in order to frame these. It helped a lot to be, you know, often psychology school or computer science or working with designers. So I can, you know, learn things. And it's interesting, a lot of conversation I had these days is really all, you know, something very good of being in academia is that we are always in a learning process. So there is no difference between students and academic here. We are all here to learn. I learned so many things today. And I think this is a very nice approach to have in, I don't know, in life and as academic. And so what are the main approach I'm using in terms of theory? So all my research is based on cultural psychology. So understanding the fundamental role played by social interaction in the development of cognition and the centrality of the community in the process of meaning making. And this is Vygotsky is one of the main author that I often use and mention in my theoretical approach, not just when you work on learning technology, but in general, everything is about increasing your understanding or designing something that can help the development of cognitive or physical skills is based on that, in my case. Another theoretical approach is distributed cognition, such as, the cognitive resources are distributed in the context, physical and social. So you have not just, distribution of information on your devices, but, Praminda mentioned that a family is important when you design for healthcare. So it's distributed across the social network and the social tissues. Another important theoretical approach for me is embodied interaction. So people create and communicate meaning through their interaction with the system and with each other through the system itself. So the system has to embody these values, has to embody these beliefs. And this is a bit, the key aspect for my research with robots. So I talk about my research evaluating and I use an ecological approach. It means that I'm looking at the overall system. So as I mentioned before, I'm designing activities. So my central unit is the activity, are the people, the context, the setting. It's not just about, the technology per se. So with the ecological approach, it means that I'm looking at everything, all the different aspects. So how I do that? Participatory design, creative problem solving, scenario-based design, speculative design, and design fiction. This is something I have used in my projects that I will present later. And of course, qualitative and ethnographic informed investigation. So all my research is mainly qualitative. And that would take a lot of time, but at the same time, for me, understanding the how and the why is, for my research, is the most important aspect. So what is the impact and the outcome of my research? First of all, I'm assessing the impact of digital technology on cognitive, literacy, and identity development. Cognitive development is pretty clear, all the psychological process that children and humans in general develop across the whole life. Literacy is related to, I've been working a lot with reading skills. But now, it can be related also to math or, technology, the use of technology and the digital literacy as well. And identity development, I have been working in the last few years about gender identity and gender biases and conscious biases that come through technology. And so the identity development is mainly referred to that type of research. And then, of course, designing technology-based transformative practice that can lead to healthy and fulfilling life. And finally, what are the outcome of my research? I mainly, of course, bit some knowledge about, how we can improve and move further, but also a bit models to better understand how things work. And the case study I'm presenting today is related to that. And guidelines on how to design and develop technology-based activities to help people to better design it. So, as you know, AI, machine learning, and robotics are like kind of delineating an unprecedented technological, techno-social realities. These, first of all, pose new ethical, moral, and social challenges, shape the construction of new discourses about their impact on society. And that's something that we need to look at, because that's very important. It's our responsibility to be responsible in which we create new discourses about the impact of AI. And of course, they also contribute to create potential discrimination caused by negative stereotypes and unconscious biases that are introduced to it. And those discrimination are related to the access of resources, but also discrimination in terms of, economic and cultural and social disadvantages population. And this can, bring to perpetuating certain social economical inequalities. So how we can face this challenge? What is our role? My role as researcher to face that, because this is my problem, right? So what I do is I address the vulnerable population, children. Why children are vulnerable? Because they cannot be self-dependent. They depend to adults for basic needs, but also for other needs, but still are a human being and they're growing. They have their mind, their needs, their beliefs. And also what I really want to do is to exploring, detecting, and mitigate the techno-social challenges in technology-based experience in order to support them. And also why this is important, because this can lead to healthy and fulfilling life, preventing future employment and social disadvantages. If you think about gender stereotypes, a lot of technology brings a lot of stereotypes related to gender, but also racial stereotypes. And so more often there are studies and statistics about how girls, this is very easy one, don't feel like they can study mathematics because they feel like a woman cannot study mathematics, right? And this can prevent future developments and of course well-being. So this is how I address the problem in my particular type of research. So my good friend Edith Ackerman, I don't know if you heard about her, she was an amazing researcher and she was working at Media Lab. And she posed this question always about how we can promote a culture that on one side is quiet, observant, thoughtful, and contemplative, but at the same time, you know, help to people to be like doers, entrepreneur, mover, and shaker. So how we can balance these two soul of a culture that is somehow healthy. So my answer to that in a lot of our conversation, I met her in '99 and she passed away a few years ago, but we had long conversation across almost 15 years, and reading her papers is part of our conversation, which is lovely. I mean, if you never read anything about her, you should. She's an excellent researcher. So I want to give children an active role in the way they can shape their reality, starting from being aware of their inner beliefs, negative stereotypes, and biases. So how we can make children to live better in these realities, because there is a lot of opacity, not trust in this AI system. So if I make them active, maybe, and make them more aware about their own beliefs in relation to the technology, maybe, you know, this could be a direction. And I really want to make children protagonists of this cultural shift, because this is what it's about. It's not anymore the child who is waiting for, you know, the technology to do something for them, but them to be active in the way they interpret the technology. So that's why I call it design for change. And I'm actually working on two different topics. The first one is about children perception, fears, and hope in interacting with social robots. And the other one is about detecting and mitigating children's unconscious biases and stereotypes. Both of them are very, let's say, critical, not easy, very controversial, let's say, from many perspectives, methodological perspective, from perspective of theory, from perspective of technology. But that's why I love it, right? Why to work in easy things? Let's go to controversial and let's open, you know, the discussion about that. So this first point, I try to understand and explore the conceptualization, concern, opportunity about fears that children might have in impact with social robots in their daily life. I will go back to this because this is the case study I'm going to show you, but this is a lot related with what Tony explained the other day. You have seen a lot of his conversation and his presentation was really around that, children understanding of what the robot was meant to do. So the outcome was to develop a cognitive models that can help us to better understand and develop activity with social robots. The other one is about gender stereotypes and unconscious biases. And actually, the objective is to make children more conscious about their own biases and their own stereotypes about themselves and the others. So how they represent themselves and how they represent the others in terms of gender stereotypes. I have been working on lots on gender identity, but recently with a student of mine, we also tackle the racial stereotype, which is another super interesting topic, but I'm not ready to talk about that. So I'm still analyzing and make up my mind about that. So we use a lot of reflective AI literacy, participatory action research in order to understand better this concept. And we built a conceptual framework to use by AI researcher and industry for less discriminatory and more inclusive algorithms. And also we have created a set of guidelines for more responsible attitude towards designing for challenging these gender biases. So these are some pictures from the gender stereotypes project. We have built 5 different dimensions and 9 different concepts, and the project was 3 different phases: detection of stereotypes in children multimedia stories. This was a lot about natural language processing, emotions, and co-design of the concept, and prototyping and evaluation. And so at the end, we came up with some, let's say, gender stereotype and gender identity is a long-term and socially construct concept. So we did an experiment that lasted 6 months, but still we need more long-term study to come up with stronger outcome. But still, with this experiment, we had very good outcome that we can base on longer activities. So I will give you the paper about that. I'm not going to talk more, but if you have any interest or question, please come and ask. I will jump to the other one. As this one, I thought it might be more interesting for you, and maybe we can generate more discussion around your interest about this topic. So people, fears and hope regarding technology play a crucial role in their lives. Parents' hope, parents' fears about children using technology is quite clear how this shape children's life. This is well known in literature, but you can see it also in everyday life. You probably had discussion with parents say, oh no, my child never used the computer, otherwise it's going to be lost, you know, or is not going to use the iPad because, you know, his eyes is going to be too tired, blah, blah, blah. So, you know, all the fears and hope of the parents, they reflect on children's lives. So there is a lot of research about that, but very little, or there is a big gap about what are the children's beliefs and fears and hope in interacting with robots in their daily lives. So I have a very nice story about this picture. In 2000, it was 2019, no, 2018. No, it was August 2019 with Paul Baxter, that was from Plymouth University, as many of you, is a robot person, I'm not. We decided to do a study with Now, and they built a perfect machine to make children cry. So in theory, on paper, everything was perfect. Now it's perfect for children. The activity was a co-reading activity, very nice book. The type of activity that we asked children to do with the robots was perfectly fine. You know, on paper, looking at the literature, everything was perfect. But actually, when we ran the study, we did with 90 children age. This is for preschoolers, but 3 to 6, we included also the primary one. It was a disaster. At a certain point, a child started crying like crazy. So I was very interesting because I was shocked and said, okay, I'm not going to do that anymore. You know, not working with children or working with robots. I was totally depressed. But after a while and discussion with other colleagues, this opened 2 interesting reflections. The first one is about failure in child-computer interaction. You know, what is important, what I learned from there. And we just, with a student, we wrote a paper about that, failure in child-computer interaction, and why we never publish about failure, but it's important for learning. And the other reflection is that maybe those children, they have some beliefs related to the robots that we have no idea about. So let's try and think about what are in their mind in order to design better activity for them. So this is how I ended up. I started to work with robots with a disaster and ended up with new research questions and try to make it happen in a way that makes sense. So in this study, we had the goal of investigating how children conceptualize social robots using hope and fears as lens. And we use intergenerational co-design workshop using fictional scenarios. And we did the online and in-person. The online was done in Washington, University of Washington by my colleague Jason Hip. The in-person was done by me in Lugano, which is in Switzerland, where part of my family is from. And when I have lived in my nomad life. So we tried to combine, we did the first online and then the in-person. And this was during COVID, so that's why we did the online first. So we collected data with audio recording and transcription of each session, and we used thematic analysis using inductive and deductive methodology. And at the end, the outcome was this model based on dichotomous hope and fears of children's perspective of the role of robots. So we use fictional scenarios. Are you familiar with fictional scenarios or speculative design? No? Who is familiar with that concept? Okay, a few people. So fictional scenarios are scenarios that represent some, real, how things would happen in a context that sounds real, but actually is not, because it depicted a future use of technology. So this methodology is often used when you cannot create a real context of for the user to practice. So we created some fictional scenarios with everyday scene. This is an example from the co-reading. We want to keep this co-reading from previous study because we really want to understand what was wrong in that study. We use prompt to get children to reflect on, about the relationship with the technology that it was represented. You can see now here. And we use 3 to 4 comic strips in order to represent different instances of the interaction. So in the first one is the robot who is reading to the child. The second one is the child reading to the robot. Third, the mother or the adults reading both. And the fourth one is the two reading together. Because each of these instances provide new insights on the feelings of children. So in the first pilot study, the goal here was really to assess the methodology. So we often, when you work with qualitative, in this kind of experimental settings, you usually do a pilot study to understand if the methodology, the protocol made sense. And we did this one with the kids team in University of Washington. We involved 12 children aged 7 to 11 years old. And we did 3 online sessions with multiple comic strips situation with robots. So we did co-reading at home, co-reading at school, play football, soccer, doing homework, online teaching, playing on swing, tidying the room. And the session 3 was about listening problem, cooking, and walking the family dog. Because we really want to understand which of those was working or not. So we built one session on top of the other. So we run the first session and say, yeah, maybe let's see the other one, and then the other one. And each scenario was picked in order to really test different situation and context by looking at collaboration versus, competitive task and caring task, compared to more agency, where the child has more agency. So the protocol was the same, 10 minutes introduction. Then we asked children to do a rating for 10 minutes of each strip. We used the 5-point Likert scale from 1 to 5. Then we had 20 minutes discussion in the group. So like, what do you think is happening here? What do you feel if you were the child? How would you change these scenarios? And then, of course, wrap up and conclusion. So at the end, we selected some specific scenarios. We try to avoid the redundancy and keeping those that stimulate more polarized reaction, hate or love. And it was so interesting to do that with American children, because American children can be extremely polarized. And that was pretty fun to see how much they were strong. Either they save everybody or they kill everybody. It was very interesting. We also use some selection criteria, different responsibilities, different locations, outdoor, indoor, private environments, public environment, like school is a public one, private is my room, and collaborative versus competitive situation, because here, are you competitive with the robots? That was so interesting. And of course, American children are extremely competitive. This is something emerged very strongly. So these are the 4 scenarios that we decided to use in the in-person study. So the robots that read to the child in the living room, the one that I show you. Then we have the robots walking the dog. The robot listened to the child's problem, and the child trained the robots, and the other children play soccer. So it was the soccer scenario, the listening to the problem, walking the dog, and reading, the co-reading one. So the in-person study was done in Switzerland. It was kind of very, let's say, lucky that we met part of an association, namely ATED in Lugano, and they do a lot of activity to involve children in learning informatics. And we had a big day, a couple of days, and I could run my study. And yeah, that was cool, actually. Less cool that all the data were in Italian and I had to analyze everything by myself, but it was very interesting. So we involved 46 children aged from 8 to 14 years old. 2 sessions, we grouped children in 4 to 3 groups, and we had 1 researcher per group. So 1 researcher was me, the other one was Giulia. She's actually the daughter of Monica Landoni, a colleague of mine. She studied psychology, and she's great. I mean, I involved her since she was 10. Now she's 21 in all my studies. So she followed me. Basically, the first time I entered a school, she was a student, a child, and now she's helping me in the studies. That's a successful story. And she studied psychology, which is cool. So she was trained by me on how to do the study. We maintained the same type of protocol as in the online because it was working very well. We had more than 13 hours of audio recording that we have transcribed and analyzed. We use thematic analysis with inductive and deductive. So I don't know how many of you are familiar with thematic analysis. Okay, so thematic analysis is an approach that we use in qualitative studies. It means that you look at all the data that you have, often are written, so you need to transcribe the data, and then you look at the themes that emerge from the data. You can do it in 2 ways. You can do it in an inductive way. So basically, you look at the theory, and then you just have a scheme, and you classify, you know, the things according to this theory. Or you can do it in the deductive way. So basically, you don't look at anything, and you just look at what type of theme emerge. And we do both ways, because this can you know, help, you know, as researchers, we use our instinct and our knowledge to analyze the data and look at what themes emerge. And then we try to balance this with the theory. So we usually use both. We were 2 people. So my colleagues from Barcelona, Laura Malinverni, she's the author of this paper as well. She helped me, she's Italian, yes, but that was pretty cool. Usually we have 2 independent researchers doing the thematic analysis and then in a blind mode, and then we go back and face and look at what the others found. It's a lot of work, but it's worth. We built 49 codes and we emerged 4 themes, and these 4 themes were the pillars for our model. So this model is represent, you know, using the lens of fears and hope, the dichotomies of children behavior towards the robots in those scenarios, so using those scenarios. So I'm saying that because children quite often show ambivalence in the way they perceive the robots in their life. The representation of this ambivalence in the model may, you know, aim at using a dichotomous lens based on hope and fears. So on the yellow parts, we have the fears. On the blue one, we have the hopes. And I will show you more in detail each of these dimensions. So the first one is boundaries and autonomy. The other one is cognitive features and comprehension skills, socio-emotional features, and materiality, physicality, and technical features. These 4 categories, they came from the thematic analysis. And the way we use in order to inform the model is we use the quotation from children in order to support the model itself. So let me know if I'm too much in the methodology, but I think this might be good for you guys to understand a bit of what is behind. So it showed kind of a quite high level of complexity. So in most of the scenario, children consider the robot as a system that are programmed and designed by somebody, a software developer or a god, something, you know, an entity which is on the top of their head. who decide the level of autonomy of the robots. In some cases, they also express beliefs related to the situation in which robot may display their own intention and agency. So in this case, related to boundaries and autonomy, robots have a full range of autonomy and are unpredictable. So lack of transparency, robots may be programmed to misbehave, human errors in robot programming make the robot unreliable. And so there's a feeling of this unpredictable behavior, even if it is connected to, the agency of the robot, but this agency is predefined by the human. So what happens if the human designed them in the wrong way? At the same time, one of the hopes is being in control of the robot agency. So on the other side, children believe that robots have no agency by design and can be predictable in the way they can be used. So you see, it's very contradictory, but the two can coexist at the same time. Cognitive features and comprehension skills. So children tending to construct their cognitive concept of robot by comparing them with human comprehension. In particular, in the reading, the listening to problem, and the dog walking scenarios, we elicited several comments from children regarding the robot cognitions. So for instance, robots are unsuitable for comprehension tasks. They believe they cannot be a good listener. Why I should read my story to a robot? It doesn't understand, right? What is the point, right? Or robot may act to literal. So if you give like a command to the robot, it might be literally doing it, like with the, it was in the soccer scenario, it was like, what if I give to the robot a command of winning and it just kill everyone in the field because it want to win? This kind of fears emerge a lot. And then, of course, understanding what does it mean taking care of human and loved ones. Maybe they cannot make it because they have no comprehension skills of the context. We talk a lot about that in the last days. On the other side, they are very useful for their knowledge because they can do large calculation and very useful for homework. So in this case, this kind of scientific tasks are perceived as, this is helpful. Regarding social emotional features, this was one of the most interesting dimensions. We had an amazing conversation with children in the in the scenario, in all the scenario, to be honest, but one of the most interesting was the one about talking about their problems. So most of the children agree that robots don't have emotions and feelings. And in the scenario, when robots demonstrate some emotional reaction, these are artificially programmed. So they are kind of like Sophia, remember the example that Tony made. So they believe that they can feel something because they're programmed to feel something. And in other scenario, the social emotional component of the situation were not so evident, and children show more nuanced understanding of robot emotion. In particular, when children imagine emotional reaction, they go beyond the program one. The output of this reaction was always associated with negative consequences. So what about the robot get angry or hurt somebody? What if, I disappoint the robot somehow and they freak out? So this kind of unpredictable and inadequate emotional reaction was one of the main fears. On the other side, the hope is that the robot can be a real companion, because if they're designed to be my companion, they can be empathize, and it's more like sympathize with my feelings. So the first one is about materiality, physical and technical features. So the role of the robot's materiality, physical and technical features has been a key topic in children conversation, especially in the food and walk, in football and walking the dog scenarios. So children often describe the robot as made of metal, steel, iron, cable, sensors, memory cards. Some of them, they have a very clear understanding how they work, interact with, connected with internet, know everything, save everything in their memory, and then, throw these cables and, sensors, have an understanding of. So it was quite interesting to listen to their perception of physicality of the robots and the technical features. On the other hand, the strength of materials can configure robots as stronger than human, and specific configuration can make them more agile. But on the other hand, they also describe robots as easy to break and fragile. So for instance, one of the fears was that what about, if the robot is walking the dog and then it starts raining and then, the robot freaks out and it kills the dog, or the dog run away and go towards the sea and the robot jump on the sea and then it's broken. Oh my God, it's so expensive. What's going to happen? So yeah, I had a lot of fun in this study. That's why I want to replicate that. So here again is a fragile, strong, interesting dichotomies. So let's say, what is our conclusion? So this model, we aimed at this model. First of all, this is a partial view. I mean, as you see, we use certain scenarios, and of course, it has to be, improved. But we hope that this is a first step of creating a model that both researcher, educators, designer can kind of consider those feelings in design for social robots. And we really hope that this outcome about can lead a new approach to design of a child-robot relationship based on invoking the positive and the negative feelings that robot can, raise in order to promote children's hopes. We haven't seen a lot of hopes. We have seen a lot of fears. So this is also, something we want to look at. So our work generates new knowledge on social interaction in this specific context. As I said, it's not, let's say, we can generalize our results, but definitely it's a partial view, right? But with qualitative, you cannot do, a lot at that point of looking very in deep of this aspect. But actually, we look at the tasks that we have selected. They're related to responsibility, engagement, private and public, outdoor, indoor locations, and also competitive and collaborative activities. So we can somehow, generalize our results. So we see two main implications here. The first one is about to design activities and scenarios around the robots. So the model can be used kind of a heuristic tool. The second one is about the design of educational robotics. So increase the opportunity of having children to critically reflect on technology. So a lot of educational activities around robotics is really about how to program robots. But here we really want to improve the critical thinking of children in terms of how to use robots and their concern and hope, and hopefully to reflect a bit better on the role in their lives. So what's going to be next? It was very inspiring, the 20 talks, and afterwards I had a meeting with Jason and Laura, and we want to explore the intersection between embodiment and acceptability of intelligent agents in children's life. So the next study would be conversational agent, animal-like robots, and we want to use Miro. We decided for that. Tony convinced us. And toy-like robots, so probably we won't use now anymore, because now it's kind of it's a toy with humanoid, semblance. So we want to use a toy. So we want to approach this research question: what is the impact of embodiment on the fears and hope model? The other one, we really want to understand how to improve the contribution of children into the design of AI. So this is something I'm exploring. It's a very recent thought. So how to integrate participatory design and speculative design approach with more technical tool like explanatory AI. And I want to lead to extract from opaque AI models useful information for the formulation of comprehensible explanation to children in order to understand better the internal structure, but also the functioning and the use. So this is, on the methodology side, that we can combine better these two different words. And we are trying to do that in medical sector with adults, with colleagues of mine. But I want to do it with children as well. So I started with design for responsible innovation. So I think that we need a shift of paradigm, right? And give people an active role in making explicit their values and beliefs in interacting with robots, because we need to include those in our processes. Try to rebalance the opportunity of children to lead the process of innovation and shape the reality, and also include industry and policy maker in promoting these research innovation outcomes. This moment of my research activity, yes, I finished. I see 3 different directions, and I mean, everybody is welcome to come and talk to me if you have ideas, collaboration around 3 different topics. The first one is challenging gender and racial stereotypes. The other one is addressing the nature deficit disorder by stimulating children's intrinsic motivation to interact with the non-human world. And the last one is identifying strategies to support the responsible development, adoption, and ethical use of AI system with and for children. So the hope and fears is going to the last points for me. Cool. So these are some relevant publications. The first one is a paper on robot walking the dog. That was a disaster. And the other one is about gender. And yeah, thanks for listening. It was a pleasure to be here. And yeah, ready for questions.
So I have like one question and more like another like discussion. So my first question is, you had, at least in the in-person study, you had children between the age of 8 to 14.
Yeah.
And we saw a lot of fear coming up.
Yeah.
And also you can use fictional scenarios that with the real robot, or where you can use experimental with robot. So my question is, do you think that some of these dichotomies that came up from the study was because of the age of the children, that was more towards 14 years old, so 14 years old don't really read books anymore, and maybe younger children would be more prone to read books, and they tend to think of robots more as machines, and you know, those aspects of reasoning about robots. And could it be also the robot itself that has impacted this perception of children about seeing now in that way, instead of seeing, for example, one robot from Star Wars, which is a kind of a different, more functional and valuable robot. So would you think if you were done a study with another robot in those fictional scenarios would have had a different impact on what children would think? So this is my question.
Okay, cool.
Age and type of robot.
Okay.
And the discussion question, we might discuss a bit later as well, is combining your 2 lines of research. Have you thought that maybe what would you think to use technology not to estimate hopes and beliefs of children about technology, but their hopes and fears and in general perceptions in the young age that might arise to trauma, depression, anxiety, ADHD in later life?
Thank you. That's a super interesting insight, actually. So I will start from the first one, age and type of robots. So you're totally right. The type of robot has an impact, because that's why we want to explore more the embodiment. So we want to do these animal-like, conversational agents and toy-like robots, because we definitely want to explore that. It's true that all the knowledge children has about robots is coming through movies. You mentioned Star Wars, through books, and so their fears definitely is not about the direct engagement with robots, but it's about their, let's say, projection of what they know about robots. And that's the most interesting part, actually, because most of the children have not direct experience with robots. That's why we have kind of selected contexts in which children had not previous experience with robots, because we really want you to understand previous knowledge related to robots, which is based on social interaction and watching movies and whatever, and their previous experience, how this can impact with the actual interaction with real robots in the future, right? So this is totally true. That's why we want to look at embodiment. The other aspect about the age, that's an interesting question. So in the pilot study, we look at younger children, 7 to 11. It was just, how do you say, it was random. We didn't really plan. I mean, during COVID, it was so difficult to find children that we take everyone we try to rationalize in the protocol and in the data analysis, but that was not the case. So we have just 2 14 years old. The others here, they were from 8 to 11 as well. So I don't think the age really impacted. I mean, if it would be with younger children, I mean, one study, I don't know, from 5 to 6, that may have an impact. But at this age, I mean, it's quite, yes, yeah. 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 Yeah, actually, yeah, we had a reflection about that as well. And we didn't find big difference, to be honest, even if the cultural, I mean, they are from US and Switzerland, wealth countries. Both of them, they have access to technology. They have access to movies. So there was not, even if there were 2 different countries, the type of data we collected, they were not so different, let's say. So we haven't found a lot of differences. So with in terms of age, I think we were fine. It would be interesting to do the study with younger children, definitely, yes. And related to the discussion aspect, that's interesting. I never thought about that, but so you mean to use fictional scenario to explore fears and hope of trauma and yeah. Mm-hmm. Yeah. Yeah. That's so interesting. I never work in this area, but I'm more than happy to talk more about that. And if you have ideas, yeah, 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 yeah. Yeah. Yeah, actually it's interesting because in our study we had American English speaking children and Italian speaking children. In the next study we'll have children from Spain, and we selected a group of children that are from immigrants group. We have children from Morecambe, which is next to Lancaster, marginalized area, low income area, and but the pilot will be done in US. So there we'll see, I think, a big change. But yeah, I'm more than happy to talk more about that. Thank you.
Thank you for your presentation. I have a question. You talked about this model that you worked on, and UX. I mean, the idea would be then for designers and engineers, people working on robots, to use this model, right, to like develop better robots. So just like taking into account some aspects that came out from the study. So, do you have an idea of how someone should use that to this? What you would expect from a designer working on these? What's the outcome of that, of a better design? What would you expect? And would you be ready to work with someone like an engineer or a designer or whoever to then develop the next cool robot?
Yeah, definitely. I think that's a very interesting question, actually. Yes, of course, I have a very clear idea how to do that. And I'm more than happy to work with anyone. If you are up to it, let's do it. Because, I mean, I think it's something that is quite interesting that is related to the opacity of the system, right? So a lot of fears are connected to some ideas that are related to the transparency of the system itself and the opacity. And if you make some of these more explicit, or you design something that are related to these specific aspects, you know, like, you know, you can address the specific fears, for instance, or specific hope, and you can try to design for it. And you don't really need to, you can look at the materiality, but also to emotional aspect. It depends a lot on, you can look at any of these. I'm just going across and say, I want to look at this aspect and the other aspect, and maybe design the system in a way that is more transparent. Yeah, I mean, I have an idea how to do it. I never really figure out the results itself, but this is something that definitely has to be done in contribution or in collaboration with designers and developers, for sure. Yes, I think what is important here is really the message. Listen, there are some fears or hope that haven't been listened, and these are, and take care of these when you design. And you can do in different way. You can do it by making children more aware of the opportunity of the robot itself. So just making it more clear. That's why I'm interested in mixing explainable AI and participatory design approach in order to understand how to make it better. And or you can design the robot itself in a way, in a certain direction. But yeah, so I see different options here. But, did I answer to your question?
Yeah, I mean, I was because being a little bit more on the technical side, yeah. Sometimes I'm just curious to see who is developing these models or as ideas in terms of just better design or whatever, like as ideas of how the design should, like a meta design, how design should be carried out. Yeah. Then if the people could also be ready to participate in the design, or it's just like ideas that are there, and then someone should, because I think that at that point, those that are proposing a model should also try to be the bridge, because it's hard sometimes for technical people to go toward those models because maybe they're far.
Definitely, yes. So there are two things here. The first one, this is it's a cognitive model. I describe a situation, okay? The next step, I give you guidelines. So design guidelines are not ready yet, but what you're asking for is design guidelines, which is different. So this is like a conceptual model to explain that something is happening. The next step, I design guidelines for people that develop. And the design of guidelines can be done in different ways, can be done in collaboration with developers and designers, can be done by multiple study. What we are doing at the moment, we try to increase and improve this model by exploring different type of embodiments. And then at the end, we might be able to create some design guidelines, but we are not ready yet.
Yes. Additional question, but I think we can take that in front of the topic. So,
of course. Thank you.